Europa is such a large moon on Jupiter. Okay, I guess I'm audible now. I hope I'm audible. Is it fine?
Yes, yes.
Okay. I'm sorry, there was some disconnection. Sir, it says host has disabled sharing screen, so I'm not able to share my screen. You can.
Just a minute, second.
Yeah, sure. Okay, I'll be able to share this. Fine. The screen is audible, I believe.
Yes, please go ahead.
Okay. So I was talking about Jupiter. Jupiter has 79 known moons. And among these 79 known moons, 4 of the Galilean moons can cover the sun completely. Because the sun is so far away from Jupiter that it appears like a very small dot. Okay. So on the Galilean moons, because of the Galilean moons, when you look at Jupiter, it covers the sun completely. Whereas the other moons will not completely cover the sun. I guess someone's mic is unmuted, so it's causing a noise. Okay. So then, yeah, these are the photos of Jupiter's eclipses as seen from the Earth. You can see there are 2 moons in this photo over here, and they are casting a shadow. If you're standing here on Jupiter, you would not be able to see the sun. So this is a very beautiful photo of Io and Europa causing an eclipse. At the same time, that's even more beautiful. Day after tomorrow on 25th, when we see the eclipse, if you are in India, you can see the eclipse. If you are in Australia, you'll not be able to see the eclipse. Or if you are in India, you can see the eclipse. Or if you are somewhere in Myanmar, you'll not be able to see the eclipse. And we have only 1 moon, so it's 1 chance. But on Jupiter, you can have, because of these 4 moons, you can be at multiple places. ಪರವಾಗಿಲ್ಲ ಮಂಗಳೂರಲ್ಲಿ ಪರವಾಗಿಲ್ಲ ನಾನು ಗೌರಿಬುದ್ನೀರಿಗೆ ಹೋಗ್ಬಿಟ್ಟು ನೋಡ್ಬಿಡ್ತೀನಿ ಅಲ್ಲೊಂದು ಇನ್ನೊಂದು ಗ್ರಹಣ ನಡೀತಿದೆ ಅಂತೆ ದಟ್ ಕೈಂಡ್ ಆಫ್ chances are there on Jupiter. And here is another image, a close-up image taken by Juno of Io, causing an eclipse on Jupiter. So these are very beautiful instances of eclipses seen on other planets. There's another beautiful image over here. Here in this image, the image on the left, you'll see there is three moons of Jupiter, right? So there's Io, there's Callisto over here, and there's Europa over here. And you can see two shadows. So this is a beautiful sight. And this is a GIF, it's not being played. Anyways, this is another beautiful image. Two moons are seen over here on screen in the frame. There's one blue one over here. There's one whitish moon over here. And there are three shadows, which means there's another moon somewhere in this direction up, or this is, oh, sorry, outside here. So this blue moon is causing a shadow over here. This shadow comes from probably this guy over here. So because of an alignment, there's a moon over here or somewhere that is causing an eclipse. So eclipses are not very rare on Jupiter. But when we talk about Saturn, the most beautiful planet in our solar system, at least in my opinion, we've got a planet in our solar system around which there are thousands and millions of rocks orbiting, such that it appears like a beautiful ring. So what about eclipses on Saturn? On Saturn, there are 82 known moons orbiting around the planet Saturn. There may be more, but there are 82 known moons. Now, when I'm talking about 82 moons, these are not the rocks orbiting Saturn within the rings. These are other rocks. Right? Then there are so many small rocks orbiting along Saturn's rings. Right? So eclipse on Saturn is a very beautiful sight, at least from outside Saturn. Like you can see the images over here. It's a very beautiful sight. On Saturn, we've got moons like Janus, Mimas, Euclideus, Rhea, Dione. These are all large enough to cause an occultation of the sun. So you can see a shadow over here on Saturn, such that if you were in this point where the shadow is falling, you would not be able to see the sun completely. I mean, you would not be seeing the sun at all. So that's a total eclipse. It's occultation of the sun by the moons. And you can have eclipses from other moons of Saturn, 75 moons of Saturn, such that it passes on the disk of the sun, small point passing through the sun. So eclipses are a common sight on Saturn. And also, the rings themselves can block the sun. You can see here that the rings themselves, the sun is probably in the lower end over here in this image. The rings themselves can cause regions on Saturn where you cannot see sunlight. This part of Saturn is actually the part where the sunlight is falling. Without the ring, it would have fallen over here, the light from the sun. But because of the rings, this region here is not able to see the sun at all. It's very black. And this region over here, the rings are partially covering the sun. It's like looking at the sun through an X-ray sheet. Don't try this, but looking at the sun through an X-ray sheet, the darkest region of an X-ray sheet, if you just pass by, you'll see the sun becomes dim and then still visible. So this is what happens. Again, let me please point out that please do not look at the sun using an X-ray sheet. I'll tell you why. Also, if by some point, I told you these rings are all rocks. So if you can find one rock around Saturn where you can land a spaceship, even there you can have eclipses. You can see here there's a beautiful eclipse of a rock passing between the rings, and there's an eclipse forming. So eclipses on Saturn is a complex event. It can be multiple events. On Uranus, let me just quickly pass through this. There are 27 known moons, of which 15 cannot cause a total eclipse or an occultation. They can only cause a transit, and the remaining can cause an occultation. You can see here in this image, Ariel is one of the moons visible, and the shadow of Ariel is also visible on Uranus. Uranus becomes a difficult site to even photograph because it's so far away. Okay. Neptune, again, there are 14 known moons. We haven't captured an eclipse on Neptune, so I don't have any image to show you, or I haven't found any if there is any. So on Neptune, out of the 14, multiple moons can cause an occultation and 9 moons can cause a transit only. So an eclipse is not something that happens only on Earth. It is not an exclusive event. It can happen around the solar system. You see here in this image, Tethys eclipsed by Saturn. Okay. So here, again, I am not able to play this video over here. It's a GIF, so it's not being autoplayed. Even moons can be eclipsed by planets when they're going, like lunar eclipse. Moons can eclipse moon. This image here is of actually a moon which is behind this main moon over here. Unfortunately, it's a GIF. You can just search for this online. Okay, moons of Saturn eclipsing each other. This is the caption you would like to give. And this is what you'll see, a moving image of this. Oh yeah, so this is what you'll see. So it was an animation I had. So you can see the moon behind the moon in the front. Rhea is moving behind Dione and its occultation of Rhea. So these are the beautiful celestial events, hide and seek events that we see. From Earth, here you can see here, Venus is being occulted by the moon. So it's not a solar eclipse, it's Venus eclipse. The moon is blocking Venus. In a while, the moon will have completely covered Venus. Here you can see Saturn's moon, Prometheus. It's coming out from occultation from behind Saturn's rings. How fascinating is this? So eclipses are not so simple. But let's come back because we have an eclipse to watch on 25th. Let's come back to the Earth. What are the eclipses on Earth? Now, before I talk about eclipses on the Earth, I'll come back to that tilt I was talking about, the inclination of the planets, or in this case, the moon and the sun. Not only is the Earth tilted by 23.5 degrees, the moon around the Earth is orbiting on a plane that itself is tilted. So I'm talking from the Earth's point of view, Bhumi inda noduvaga, sun appears to move from east to west, so it's appearing to move around the Earth, okay? And so it's got a plane. We call this the ecliptic. It's actually the Earth going around the sun, but from our point of view, it looks like the sun is going on around the moon on a floor, on a land, like it's an orbit. Now here on Earth, the moon is also going around the Earth. So that also has an orbital plane. So that is also a plane. And these planes are not the same. The moon's plane is tilted by just 5 degrees, very small angle. But when you compare them close by, they are still tilted. You can see that clearly in an image over here. So the moon's orbit, because of this 5-degree tilt, only when it comes at these points known as the lunar nodes, we can see an eclipse. In the bottom image, you can see beautifully how the 5 degrees tilt is, right? So this red line you see at the bottom is actually the direction to the sun. Sun is located far, far, far away in this direction. And the moon is tilted at 5 degrees. So only when the moon goes around this orbit, goes around the Earth, and it reaches this point, where it is near this point here like this, okay? So if the laser point is the moon and you are the sun, you looking at the screen is the sun, then when the moon is here, you can have a eclipse, right? But if the sun is over here, somewhere in this side over here, and the moon is in between the Earth and the sun, right? The moon is in between the Earth and the sun. I can draw it for you if you want. So let's say the sun is over here. Okay, the sun is over here, moon is going around the Earth, and now the moon is between the sun and the Earth. But it is so small, so far away that this 5 degrees is enough to cause the light or the shadow of the moon to not fall on the Earth. This is the beauty of it. So if this 5 degrees decreases when the moon is near the nodes, the moon will be somewhere here, then they are in a straight line there. So an eclipse is caused. But because of this 5 degrees, every new moon is not going to be an eclipse. ಈ 5 ಡಿಗ್ರಿ ಇಲ್ಲ ಅಂತಂದ್ರೆ ಪ್ರತಿ ಅಮಾವಾಸ್ಯೆ ಒಂದು ಸೂರ್ಯಗ್ರಹಣ ಇತ್ತು, ಪ್ರತಿ ಹುಣ್ಣಿಮೆಯಲ್ಲಿ ಒಂದು ಚಂದ್ರಗ್ರಹಣ. We should say, we must thank whoever created the universe for setting the sizes exactly right, or setting our lifetimes to be in this time, such that right now from the Earth, if you look at the moon and if you look at the sun using a solar filter of sorts, then both of their sizes are almost the same thing. It's very beautiful. And we are very lucky for this to happen. Because we say the moon's orbit is decreasing, or at one point it was much larger. So moon was farther from the Earth than it is today. Or it's getting smaller and smaller. The orbit is getting smaller. It's coming closer and closer. So right now, at this point of time, let's say 2022, this 20th, 21st century, we are very lucky. Because right now, the moon size and the sun size is almost the same. Again, almost is a very important concept. You all can do this exercise. Students can do this exercise where you find the average distance of the sun from the Earth. and you calculate the angular size of the sun. These are values you can get on Google easily. And then you calculate the average distance of the moon from Earth, and you can calculate the average size of moon, the angular size. And you find the ratio of the distance to size for the sun and the moon, then you'll find both the ratios are almost equal. This is the key here. And what will this lead to? Let me explain. So when we talk about eclipses on Earth, there are three types of eclipses on Earth. There's a partial eclipse, there's an annular eclipse, and there's a total eclipse. What's going to happen on 25th October is the partial eclipse. So let me quickly explain to you the different types of eclipses on the Earth. So how do these eclipses form? Whenever there's an object, there is a shadow to the object when there is light behind it. And these shadow, where do you fall on the shadow? That is what tells you what kind of eclipse it's going to be. Or in this image here, to put it to you more simpler, if something is covering the object in the background, partially, ardha cover agta ide, chur bhaga cover agta ide, then it's a partial eclipse. You can see here in this image, you've got a light bulb, you've got a basketball, but it's not aligned properly to the observer. In the image, it may look like it's a straight line, but to the observer, this is the line, and it's not aligned properly. Basketball is slightly above, which means the basketball is not going to cover the entire bulb, it's only going to cover the partial bulb. Or for example, if my hand is covering my face partially like this, whatever the distance, it's covering partially my face, some amount of face is still visible, then it's a partial eclipse. A total eclipse is when the object is occulting the object in the background, or when the moon is occulting the sun, right? A total eclipse is when the moon completely covers the sun. That is the point when you cannot see the sun at all. On the screen, you cannot see the flashlight at all. You can see only the basketball. In that case, it's a total eclipse. Then we've got an annular eclipse. This is a very rare, beautiful eclipse, such that the object in the background is large and the object in the foreground is small, and you can still see the edges of the object in the background. In the video feed, if you take my face to be the sun, and this object here is the moon, so when it is very close to you, it's going to look like a total eclipse. If it's slightly to the side, you can see it's a partial eclipse. And if it is far away, because the object is very small, if it is far away, you can still see my face, right? And an annular eclipse, in case of the moon and the sun, it's somewhat like this. You can see the outer edges of my face, and the moon is covering the center of my face. The same thing is the case over here in the image on screen. The basketball is covering the bulb, but not completely. The outer edges are visible. So these are the three types of solar eclipses, and this is how they appear. A partial eclipse is when the solar disk is covered slightly. A total eclipse is when the Earth's disk is completely covered. And an annular eclipse is when the edge of the sun is visible. Annular because it appears like a ring, right? And also remember, when we talk about eclipses and shadows, every shadow has two regions. One is umbra and penumbra. So umbra is the actual shadow that appears, and the penumbra is the blur edges of a shadow that you usually see. So if you have any kind of light source around you right now, and you can see the shadow of an object because of that light source, if you move the object away from the screen, then you'll see there are blurred edges. These are penumbra, right? So a solar eclipse that is partial occurs when the observer lies in the penumbra or the partial eclipse region. So you can see here, of course, distance is not very close like this. It's just for you to understand. The moon is in between the Earth and the sun. The moon is here in between them, but not perfectly aligned. And the south pole of the Earth is in the region where the penumbra of the Earth is falling. So the 25th October eclipse is exactly this. But the moon is in the northern region. The moon will be somewhere here on 25th. So this is what is happening. The moon is going to be here, and the northern hemisphere is going to be in the penumbra or penumbral shadow of the moon. That is why everywhere on Earth, wherever you can see the eclipse on 25th, it's a penumbral eclipse. Sorry, it's not a penumbral, it's a partial eclipse, right? Not a penumbral eclipse. In case of a total eclipse, this is what happens. It's a perfect alignment of the sun, moon, and the Earth. And you can see only a small region on Earth here is able to experience this total eclipse at a time. If the moon passes like this downwards, then this region where the eclipse is happening is also going to pass. But also remember, there are regions which fall under the penumbra of the moon during a total eclipse. These regions will experience a partial eclipse. Sometimes these regions will see a partial eclipse. Usually a partial eclipse begins, a total eclipse begins like a partial eclipse and then eclipses totally and then slightly moves like this and exits partially. But there are points on Earth during a total eclipse where the eclipse can be seen only partially. This is usually the case for astronomers, where there's a total eclipse happening in Delhi, and we in Karnataka will see it only as a partial eclipse. We're very disappointed. So it's because of this case. The penumbra and the umbra are what decides if it's going to be the partial or the total eclipse. And an annular eclipse is a beautiful case when the moon is away from the Earth. You can see here you can see the moon is away from the Earth between these two images. Why does this happen? Because the moon is going in an elliptical path. The moon is going in an elliptical path. There are points where the moon is close to the Earth. There are points where the moon is away from the Earth. So just like with this object I showed you, you can see the video feed right now. This object can cover my face completely. And when it goes slightly away, my edges of my face are visible. Move forward, covers my face. Move away, slightly visible. So this is what happens in case of an eclipse, annular eclipse. So that region, which is not the umbra or the penumbra, slightly extended umbra is known as the antumbra. And that is where the annular eclipse is. There's also a penumbral region here where you can see it as a partial eclipse. So again, coming back to lucky us, why is it that we are lucky? Now that you know what an annular eclipse is, now that you know what a total eclipse is, I told you on Mars, the two moons are so small that they will never cover the sun completely. They will only pass in front of the sun. In case of Jupiter, you have 4 moons, the Galilean moons, that can completely cover the sun. But there are other moons that cannot cover the sun. They'll just pass in front of the sun. So on Jupiter, on Mars, on Saturn, you cannot have a total eclipse and an annular eclipse because of the same moon. On Jupiter, because of Europa, whenever there's an eclipse because of Europa, it is always a total eclipse. On Jupiter, on any other non-Galilean moons, or for example, Phobos on Mars, it's always an annular eclipse or a transit. But in case of Earth, the moon right now in the 19th, 20th, 18th, 17th, 16th, all of this millennia perhaps, the moon is exactly that point where sometimes it appears close to us and it causes a total eclipse, and then it's going to cause an annular eclipse. And as the moon's orbit becomes closer and closer to the Earth, in the future, after 1,000, 2,000 years, you will never be able to see an annular eclipse on Earth because of the moon. That is why the sizes match perfectly right now. So we are very lucky. But we are also unlucky because I told you, whenever there's a total eclipse or whenever there's an annular eclipse, there's a belt like this usually. And because of this belt, there are other regions that do not fall on this belt, which experience an partial eclipse, even though this belt is experiencing a total eclipse. Okay, so this is the image of the annular eclipse from 2019. You can see within this belt, it passed through Mangalore, it passed through Kerala and Tamil Nadu regions. Then it went into Indonesia, Philippines, and so on and so forth. Here it was passing through the Saudi Arabian region slightly, then Oman, Bahrain, and so on. But you can see Dubai here does not fall on the belt. In India, Delhi does not fall on the belt. In fact, Udupi was also not exactly on this belt. So these regions did not see an annular eclipse at all. So we are unlucky because whenever an eclipse happens, it's not going to be always a total or an annular eclipse. It may be total somewhere, but on some regions, it's always going to be a partial eclipse. So this is the case. Right? So, are we ready to look at the eclipse now that we know what an eclipse is? Now that you are going to move forward and look at the eclipse on 25th October, are you really ready? Not yet. Let me complete. To view an eclipse, never, ever, ever use any object with a lens or a glass. Do not use binoculars, do not use telescopes, do not use cameras or even sunglasses or goggles. Do not use any optical device to view at an eclipse. Do not use especially telescopes, because you will have paid so much for the telescope. I want to look at an eclipse, or binoculars. No. When you are looking at an eclipse, you need specialized filters, as you can see in this image. If you have a binocular, you need 2 of those. If you have a telescope, you need 1 cap that fits onto the face of the telescope or the objective of the telescope, that will prevent the sunlight from completely entering the telescope, and it will filter out, and only the brightest region will be completely filtered out, and it will appear to you very safely. Or you have an eclipse goggles. This is what many of us will experience. Wear an eclipse goggles and look at the sun. And you can see during an eclipse, you can safely view the eclipse using a goggles. It's very cheap also, right? So this is an image from our college. Our principal, Dr. A.P. Bhatt, was also there. We've got PJ Bhatt and Nivedita ma'am from ISRO. Both of them are from ISRO. They were here with us during the eclipse. You can see some of them are using goggles over here. A.P. Bhatt sir and Nivedita ma'am are using something known as a welding glass. Okay. Again, welding glass, don't simply go buy a welding glass to look at the eclipse. There is a certain grade, 14 grade or higher is required for a welding glass for you to safely view the eclipse. So these are various methods. Or if you don't want to go out and buy stuff, it's very easy. If you have a binocular or a telescope and you still want to see an eclipse but cannot buy a filter because they're expensive, still easy. Don't look at it directly. When you have an optics device, you use paper in front of the eyepiece region and then slowly move it away such that it is focused and you can see the eclipse projected onto the paper. Or no optical device, no problem. Take an opaque cardboard sheet, make a small hole using a pin, and then make a pinhole. And then again, that can be used to project the sunlight, right? So here, sun is somewhere here on the top. So it's going to project the light, okay? And this is going to project the eclipse. So this is how you view the eclipse safely. Here's a small project that students can do. It's called an eclipse viewer box or pinhole box. So you take a normal box, a shoe box, or any other bigger box. Making a hole with the box is not a good idea because these cardboard boxes are usually thin. So you make a hole, okay, make a hole with a pen. And then on top of that hole, you take a small aluminum foil and you make a pinhole with it. And then you try to look at the sun. You point this hole at the sun. To see it more clearly, it's better if you tape a white paper from the inner side of the box. And then here it says your head goes here, you make a hole. But tomorrow, don't call me saying, sir, my head is not going inside this box. It's too small. No, you can remove that side completely. You can keep it open. Then when you point it at the sun, this hole, when you point it at the sun, this box will project, this hole will project the image of the eclipsed sun very beautifully, safely, no problem at all. So during an eclipse, we should all go out and watch. And on 25th October, what is going to happen? I told you, nowhere on earth, the moon is going to completely cover the sun. This is an all-in-all partial eclipse, and various regions in the European countries, Central Asia, and certain African regions, you will have the eclipse visible. So this center region that you see over here, in Russia, slightly a part of, I think, Kazakhstan, you've got 80% of the sun being covered. This region, most of Russia and the old countries that belong to the Soviet Union today that are independent, Afghanistan, the tip of Afghanistan, and bit of, I believe, is Sweden and Finland, if I'm not wrong. These regions can see 60% coverage. North of India, Leh, Ladakh, Delhi, Pakistan, Iran, and top of Saudi Arabia, some European countries, Sweden, Norway, and all, the 40% coverage of the sun. So this is how the eclipse looks like. In India, I told you 40% of the sun is covered. In fact, if you go to Ladakh, 50% of the sun will be covered. New Delhi, 40% coverage. As you move south, that coverage becomes less. Gujarat, Maharashtra, you can see the sun will be covered for about 30%, 20%, up to 20% can be seen. South India, all of South India, where Karnataka lies in, we can see about 10%. In Karnataka, it's about 9 to 12%, depending upon where you live. So this is how you see the eclipse, right? These are the regions to see the eclipse. If you are in any other country that does not fall in this region, for example, Australian regions, or East Asian regions, or United States, you cannot see the eclipse, right? So in Gauribidnur, or where this talk is being relayed right now, Gauribidnur specifically, the eclipse starts at 5:09 p.m. It's going to go on for 1 hour 17 minutes till 5:55 p.m. Okay. Yeah. So the duration might show a slightly longer phase. So just check it between 5:10 to 5:55. You'll have the eclipse, and the maximum eclipse will occur at 5:49. Okay. And you will see about 11.3% of the sun will be covered. It's very nice. Gauribidnur will see a good number of coverage of the sun, 11.3%. Here in Udupi, wherever I'm talking from, it's again the same thing, 11.2 or something. So we'll be able to see the eclipse very beautifully with the goggles also. You don't need a telescope specifically. Okay. So be ready. People of Gauribidnur, be ready. Even other places, if you're listening from other places, you can just go online and search for it. Or this is a good website where I've taken this image from, timeanddate.com, where you can just go and search for your location, and then it will tell you exactly what time the eclipse begins and it ends. So yeah, so this is a close-up. You can see here in the North India, there's a more coverage over here, or darker regions. North India, around Uttar Pradesh and all, slightly less. And this is where we are. We are all in this region. Okay. So Gauribidnur, like I've told you about the time, here the duration is fine. It's 46 minutes. Starts at 5:09, ends at 5:55. The timing is given in 24 hours. Pardon me for that. So maximum eclipse for you, it occurs at 5:49. Okay. This is the maximum view, simulated view of the eclipse. So this is an animation enabled, taken from the same website, where they show you how the moon will approach the sun. So the eclipse will start at 5:09. It touches the sun's disk. The moon will pass through the sun, covering the sun, and about maximum eclipse. This is the coverage. And then look at the beauty here. Wait, let me play it again. Let me play it again. Look at this beautiful eclipse here. You're looking at the sun. You're looking at the sun. The eclipse begins. Nicely, the moon is going to cover the sun for about 11-12%. You're you're still looking at the sun, and it disappears. And it did not disappear because of an eclipse. It disappeared because the sun was about to set. That is the beauty of this eclipse. The eclipsed sun is going to set slowly over the western horizon on 25th October. That is the most beautiful thing. Otherwise, this is nothing but a boring eclipse, just 10% of the sun. It's very difficult to see in some cases. But no, this eclipse happens because, during the time of a setting sun. That is why it's very beautiful. So how will you see this eclipse? You have to head over to a place where the western horizon is clearly visible. Okay. At this point, I'm very fortunate to be living in Udupi because we've got the western coast of India. We have a beach over here, so I can see the horizon very clearly. But don't worry, if you're not in a coastal town, you go to any building in your area that has about 4, 5, 6 floors. Okay. Or you climb a hilltop if it's available. You climb the tallest building, and then you'll be able to see the horizon. And then you'll see the sun being eclipsed at 5:09, and slowly at 5:49, the sun will be very close to the horizon, very, very close to the horizon, still at maximum eclipse, still eclipsed sun. And within no time, the sun will disappear from the horizon. And the eclipsed sun is usually red in color. So with the eclipsed goggles, if you've got the goggles that make your sun appear orange, the eclipse is going to be very beautiful. And as you wear the goggles and look at the eclipse, as the sun sets, you can see, here only I'll show you. You can see as the sun sets, around at this point, you will not be able to see the lower part of the sun. Wearing the goggles when you're looking at the sun, the upper edge is being eaten by the moon, the lower edge is being eaten by the horizon. So you're going to get this weird shape like the blade of an axe for the sun. That is the most beautiful thing about this eclipse. And that is why I urge every one of you to head out and watch the eclipse. Now, quickly, because we are talking about the eclipse, let me talk about lunar eclipse. Very easy case. Lunar eclipse is when the moon goes behind the earth, as I've shown over here. Okay, the moon goes behind the earth and it falls in this region. And because the earth is a larger object, the umbra and penumbra are much larger. So the moon will easily be captured inside the umbra. Okay, but because of alignment problems, sometimes the moon will not pass through the umbra. So you can have a lunar eclipse that is in the umbra or penumbra. We'll call it an umbral eclipse or a penumbral eclipse. Okay, just like a solar eclipse, this is the same alignment issue. But one more thing I want to point out is usually during a total eclipse, the moon turns red. Rakta Chandra, red blood moon, the iron rust moon, whatever it is. Why does the moon appear red? The image here on the right side, lower right, will tell you why. This is the view of the moon, view from the moon of the earth during a total lunar eclipse. You can see in the image on the left over here, the moon is completely in this dark region where it cannot see the sun whatsoever. So there is no sun for the moon to be lighting up. But there is still light coming from the earth. And it's not these street lights or big building lights or city lights that we emit into space. No. We see an edge of the earth, and that is because of the dispersion of sunlight through the atmosphere, that all the red light bends towards the earth's curvature and then is moving forward and reaches the moon. And from the moon, when you look at the earth, it's going to appear like this beautiful red ring, right? So even total lunar eclipse is an annular eclipse. Okay. So this is all about the eclipse there is. Right? Initially, when I was introduced, they mentioned Purna Prajna Amateur Astronomers Club. So I just want to quickly introduce the club to all of you who are not listening from Udupi. Purna Prajna Amateur Astronomers Club is the club from where I am. I am running this club as the coordinator right now, and this club has a history of about 40 years, almost 40 years, conducting programs like you see in this image. We conduct skywatch programs during an eclipse, after an eclipse, solar view, or even night sky view programs, stargazing programs. We also conduct talks here. Okay, so if any one of you is ever in Udupi, you can easily contact me and reach back. But even if you're not going to come to Udupi, or if you're not planned to come to Udupi, you can still access PAC using our website. This website that is shown on the screen is the PAC's website, and you can access it from any device very easily. Okay, and on this website, what will you find? You will find links to live streams. I told you during the annular eclipse in Udupi, we could not see the annular eclipse completely. In Mangalore, we could see the ring of the sun. Whereas in Delhi, it was just a partial eclipse. So if you're living far away from any place and by chance we have an eclipse in Udupi, Mangalore region, we will live stream it for you. Also, whenever there's an occultation, last year in April, there was a lunar occultation of Mars, which was only visible in Mangalore, Udupi regions. Okay, so lunar occultation of Mars, people in Gauribudnur could not observe it. Okay, for you, it would appear like Mars is very close to the moon, but here the moon was covering Mars completely. So in such case, we organize live streams so all of you can come in. Zero shadow day. This is something is also very important in terms of astronomy. You can just come to our site and understand what it is. I'll not waste further time trying to explain what zero shadow day is. But basically, you can have all live events. But the highlight is whenever you want to learn astronomy, we can go online and search. And whenever you search for something online, there are multiple results, multiple definitions. So at PAC, we'll make it easy for you using these posters. If any of you teachers or principals or headmasters are listening, please head over to PAC website or ask your teachers to. Students, ask your teachers to. You yourself, please go to the website. You'll find so many posters about astronomy. Both you can see in English and Kannada. So with this, you can understand astronomy easily. I'm working on the solar eclipse poster right now. Maybe today or tomorrow, I'll release it on the website. And of course, we've got a planisphere. How the night sky looks. It's a whole different topic for a talk. So some other day, I will give a presentation if invited on the night sky itself. But how do you know this? How do you know where is which star? There are activities on our website. Unfortunately, I could not put the images here. Have you ever heard of astronomy crossword before? We've got crosswords on newspapers every day. It does general crossword, but there are also astronomy crosswords. We've got multiple activities on our website. So I request all of you to head over to PAC website and listen. Listen to our talks, which are posted there. Check it from time to time for live events and take part in these activities. And also, I want to point out, because Srinath sir was here recently, I know him from there. We met at the Pilikula Regional Science Center. For our region, the Mangalore-Udupi region, there's a beautiful, very well-equipped science center for all of you people who are living outside Mangalore and Udupi regions. The Pilikula Regional Science Center has a separate science center, which is enormous in size, covers so many different domains of science, and has got a beautiful infrastructure, well-equipped infrastructure. Along with it, it's got currently Asia's biggest 3D planetarium. So you have to, if you are ever in Mangalore or Udupi region, please head over to Mangalore, head over to Pilikula and look at the planetarium, go look at the shows there and understand and enjoy astronomy through this. If you're ever in Udupi, please contact me through PAC. You can contact me. My email ID is on the screen if you want. And also for all of you listening, if you want to take part in PAC activities at your convenience without coming to Udupi, you still have an option. Simply follow PAC. At the bottom, you've got a link over here to the PAC website. You just add /social. And from there, it will take you to a WhatsApp group, which you can join, where you'll get daily posts on astronomy to learn stuff. It'll take you to a Telegram group where you yourself can talk and participate in astronomy discussions. You can go to our YouTube channel where we've described every single month how the night sky looks. In Kannada, it says, "E tingal akasha." AP Bhatt sir, our former convener, has demonstrated and described the night sky beautifully. In English, you listen to the same old voice that you're listening to right now. And we've got the night sky and various other events. And if you want to head over to Facebook, we've got activities there. So many things. Again, describing my PAC website itself is a 1 hour talk if you want. But anyways, so these are the various resources all of you can utilize. PAC is always at your service. Pilikula Regional Science Center is always there for you to come and visit and learn astronomy from. So please, all of you listening to this talk, visit these places, learn from the night sky. And I hope every one of you watches this eclipse on the 25th of October. Just find the right spot where you can see the western horizon. No tree will obstruct your view. Ensure you've got the eclipse viewing goggles, because you don't want to look at the eclipse without the goggles. ಯಾರಾದ್ರೂ ಎಕ್ಸ್ರೇ ಶೀಟ್ ಇಟ್ಕೊಂಡು ನೋಡೋರಿದ್ರೆ ದಯವಿಟ್ಟು ಈಗಲೇ ಹೇಳ್ತಿದ್ದೇನೆ, ನೋಡ್ಬೇಡಿ. ಎಕ್ಸ್ರೇ ಶೀಟ್ಸ್ ಮೇಲೆ ಮೈಕ್ರೋ ಬಬಲ್ಸ್ ಇರುತ್ತೆ, ಚಿಕ್ಕದಾಗಿರೋ ತೂತ್ ಇರುತ್ತೆ, ಚಿಕ್ಕದಾಗಿರೋ ಒಂದು ತೂತಿನ ತರ ಟ್ರಾನ್ಸ್ಪರೆಂಟ್ ರೀಜನ್ ಇರುತ್ತೆ. ಸನ್ ತುಂಬಾ ಬ್ರೈಟ್ ಇದ್ದಾಗ ಅಲ್ಟ್ರಾವೈಲೆಟ್ ರೇಸ್ ಅದರಿಂದ ಪಾಸ್ ಆದ್ರೆ ನಮ್ ಕಣ್ಣಿಗೆ ಹಾನಿ ಆಗ್ಬೋದು. ಕಣ್ಣಿರೋದೇ 2, ಅದನ್ನ ಕಳ್ಕೊಳಕ್ ಆಗಲ್ಲ. ಬಟ್ ಮೋರ್ ಇಂಪಾರ್ಟೆಂಟ್ಲಿ, ಗ್ರಹಣ ನೋಡ್ಕೊಂಡು ನಮ್ ಕಣ್ ಎಲ್ಲಾದ್ರೂ ಡ್ಯಾಮೇಜ್ ಆಗ್ಬಿಟ್ರೆ, ಸಿಂಪಲ್ ಆಗಿ ಡ್ಯಾಮೇಜ್ ಆಗ್ಬಿಟ್ರೆ, ದ ಪ್ರಾಬ್ಲಮ್ ಇಸ್ ವಿ ವಿಲ್ ನಾಟ್ ಬಿ ಏಬಲ್ ಟು ಐಡೆಂಟಿಫೈ ಇಟ್ ಫಾರ್ ಅ ಲಾಂಗ್ ಟೈಮ್. ಸೊ ಇವತ್ತು ನಾನು ಗ್ರಹಣ ಬರಿಗಣ್ಣಲ್ಲೇ ನೋಡ್ತೀನಿ, ಪರವಾಗಿಲ್ಲ ಏನಾಗತ್ ನೋಡೋಣ ಅಂತಿದ್ರೆ, ನನಗೆ ಇವತ್ತೇನಾಗಲ್ಲ, ನಾಳೆ ನಾಡಿದ್ದು 5 ವರ್ಷ ಬಿಟ್ಟು ಡಾಕ್ಟರ್ ಹತ್ರ ಹೋದಾಗ, ಅಯ್ಯೋ ಸುಟ್ಟೋಗಿದ್ಯಲ್ಲ ಈ ರೆಟಿನಾ ಒಂಚೂರು ಅಂತ ಹೇಳಿದಾಗ, ಅಯ್ಯೋ ನಾನು ನೋಡ್ಬಾರ್ದಿತ್ತು ಅಂತ ಅನ್ಕೊಳ್ಬೋದು, ಮಾತ್ರ ಏನು ಮಾಡಬೇಕು. So I wish all of you all the best to view the eclipse on 25th. And if you got any questions on the eclipses or this eclipse in particular, it's welcome. Thank you, everyone.
ಥ್ಯಾಂಕ್ ಯು ಸರ್. ಯಾರಿಗಾದ್ರೆ ಏನಾದ್ರು ಡೌಟ್ ಇದ್ರೆ ಕೇಳ್ಬೋದು. ಈಗ ಇಂಟರಾಕ್ಟಿವ್ Q&A ಸೆಷನ್ ಇದೆ.
Fanindra, you can unmute others.
Okay, sir.
Or if they can raise hands, you can allow them to speak.
They can unmute themselves to ask now.
Yeah, Ganesh can ask. Ganesh, you can unmute and ask.
Sir, kelsidiya sir?
Yes, please go ahead. Ask him.
Solar eclipse ಇದೆ ಅಲ್ಲ, ಸೊ ಅವತ್ತು ಧರ್ಮಸ್ಥಳ ಮನ್ನಾಸಂ ಟೆಂಪಲ್ ಸ್ವಲ್ಪ ಅವರ್ಸ್ ಉಂಟಂತೆ. ಬಟ್ ಸೋಲಾರ್ ಎಕ್ಲಿಪ್ಸ್ ಗೆ ಮತ್ತೆ ದೇವಸ್ಥಾನಕ್ಕೆ ಯೂಸ್ ಆಗೋದಕ್ಕೆ ಏನ್ ಸರ್? and scientific reason ಏನು ಸರ್?
Eclipse
you got the question. ನನಗೆ ಅರ್ಥ ಆಯ್ತು. ಪರವಾಗಿಲ್ಲ.
ಒಂದ್ ಸ್ವಲ್ಪ ಮ್ಯೂಟ್ ಡಿಸ್ಟರ್ಬೆನ್ಸ್ ಬರ್ತದೆ.
ಟೆಂಪಲ್ ಕ್ಲೋಸರ್ ರಿಲೇಟೆಡ್ ಕ್ವೆಶ್ಚನ್ ತರ ಅನಿಸ್ತದೆ.
ಹೌದು. ಅದೇ ಹೇಳ್ತಾ ಇದ್ದೆ.
ಟೆಂಪಲ್ಸ್ ಅಲ್ಲಿ ಕ್ಲೋಸ್ చేస్తారు.
Got the question.
Yes. Usually eclipse talk ಮುಗಿಬೇಕಾದ್ರೆ ಒಂದು ಕ್ವಶನ್ ಇದೊಂದು ಇರುತ್ತೆ. ಬಟ್ ಎನಿವೇಸ್, ಬೇಸಿಕ್ಲಿ ಡ್ಯೂರಿಂಗ್ ಅನ್ ಎಕ್ಲಿಪ್ಸ್ ನಾವೆಲ್ಲ ಕೆಲವೊಮ್ಮೆ ದೇವಸ್ಥಾನ ಮುಚ್ತಾರೆ, ಕೆಲವರು ಮನುಷ್ಯರೇ ಹೊರಗೆ ಬರಲ್ಲ, ಉಪಹಾರ ತಗೊಳ್ಳಲ್ಲ, ಊಟ ಮಾಡಲ್ಲ, ಉಪವಾಸ ಮಾಡ್ತಾರೆ. All of these are ancient beliefs. Without any modern technology, not what would have happened. I can only guess from here because we don't have any scientific evidence of these things directly. The only science behind an eclipse being harmful is to your eyes when you look at it directly. That is the whole science of it, basically. Beyond that, there isn't anything dangerous. Of course, Suryaninda yavaglu we have ultraviolet radiation. If you go out in the sun and stand in the afternoon, in the mid-afternoon, we'll have burning sensation because there's infrared radiation coming. Tumba hot nintkonಡ್ರೆ ನಾವು ಸೂರ್ಯದಂಡ್ರಲ್ಲಿ, if it is too much exposure to very bright sun in the afternoon, then sometimes the skin will peel off. It will become much dark and peel off, becomes red also sometimes. That is because we've got ultraviolet radiation that is going to burn the skin also. But the eyes are something which cannot simply peel off a skin and fix it. Hagagi, when you look at an eclipse directly, will have an effect on our eyes. And I can only guess that in the ancient time, many people looked at the eclipse directly. Curiosity is also there. The moon, when it covers the sun, it becomes slightly dim. Many of us will feel like, something is happening, let's look more closely. Our pupils dilate and we put all our might into looking at the sun. So avagénagatte, these ultraviolet rays can enter our eyes and damage our eyes. So many people have probably seen the eclipse and their eyes have been damaged. Hagagi unknown factor indagi ಏನು ಉಪಹಾರ ತಗೋಬೇಡಿ, ದೇವರಿಗೆ ಏನು ಪ್ರಾಬ್ಲಮ್ ಆಗೋದು ಬೇಡ, ಈ ತರ ಹಾರ್ಮ್ಫುಲ್ ರೇಡಿಯೇಷನ್ ದೇವಸ್ಥಾನದ ಒಳಗೆ ಬರೋದು ಬೇಡ. ಅದಕ್ಕೊಂದು ಪವಿತ್ರವಾದ ಒಂದು ಸ್ಥಳ, ಅದೊಂದು ಶುದ್ಧವಾಗಿರುತ್ತೆ, ಅದಕ್ಕೇನು ಇನ್ಫಿಲ್ಟ್ರೇಟ್ ಆಗೋದು ಬೇಡ. ಅಂಡ್ ದೇರ್ ಆರ್ ಆಲ್ಸೋ ಸ್ಟೋರೀಸ್ ಅಬೌಟ್ ರಾಹು ಅಂಡ್ ಕೇತು. In mythology, Rahu and Ketu were basically Rakshasas that swallowed the sun and all that. So when there is a Rahu is swallowing this sun during a total eclipse or a partial eclipse, they probably believe that his power is very high, so let it not enter the temples. So probably they would shut down the temples. They would not eat anything. Ivattu ನನ್ನ ಮನೆಯಲ್ಲೂ ಫುಡ್ ಮೇಲೆಲ್ಲ ಒಂದು ಗರಿಕೆ ಅನ್ನೋ ಒಂದು ಸಣ್ಣ ಗ್ರಾಸ್ ಇಡ್ತಾರೆ. ಸೊ ಇದೆಲ್ಲ these are all precautions, I must say. Scientifically, ತುಂಬಾ ಜನ, of course, many organizations try to organize eating food during eclipse. ನಾವು ಅದೆಲ್ಲ ಮಾಡಿ ಅನ್ನಲ್ಲ, ಮಾಡಬೇಡಿ ಅನ್ನಲ್ಲ, because it's all left to your belief. If I believe in such kind of things, then I would rather put myself inside the doors and stand near a window and view the eclipse. So my concern here is view the eclipse. If you can go out, because from my personal experience, I have viewed 3 eclipses, 1 total eclipse when I was a very small child, so I don't remember it exactly, but I remember going outside because it was dark. Recently, 1 partial eclipse, 1 annular eclipse which happened in Udupi itself. The entire duration of the eclipse, I was with a telescope. I am alive, no healthy, no problem. My skin is not burnt, but I haven't seen the eclipse directly without a filter. That risk I would never take, because science has told me that ultraviolet radiation can burn my eyes. So the only science that we know for sure is ultraviolet radiation. I usually avoid answering such questions. If temple is closed, why is it closed and stuff, because we don't know. Simple as that. Being a science teacher myself, I don't want to say that is false, because tomorrow there may be another paper that says it is affecting. That time I have to change my views. That is how science works. But right now there is nothing, and I don't need to stay away from the eclipse. From my experience, at least, there is nothing. Beyond that, if something is going to happen to me after 30 years, I'm sorry, I can't help it. But right now I'm well and fine. Nothing has happened to me during the the annular eclipse. I was entirely from 9:24 to 11:20. I was completely outside under the sun, seeing the eclipse. through the telescope, through the camera, with the filter and the goggles. Nothing has happened to me. Nothing has happened to my memory. And I believe I'm healthy enough. So going out and looking at the eclipse is fine. Why exactly are temples closed? Someday, if we have an answer, probably I'll be able to answer. Until then, simplest answer, I don't know.
Others have any question? You can raise and ask the question.
Good evening, sir. This is Srinivas.
Hello, Srinivas.
Thank you, sir. It was really great to hear you.
Thank you.
And I have two doubts.
Okay.
I have heard something called path of totality. So what
Okay.
it is?
Okay.
And one more doubt is actually really what goes in the prediction of eclipse, like how we are predicting. Because our ancestors were predicting eclipses year before when it happens actually.
Yes.
So please clarify this.
Fine. Let me just show you what the path of totality is. I had it on my slide, so I'll utilize it. Okay. So if you remember when I said we are all unlucky because the eclipse happens only in a small region. So this is the case. So path of totality is basically the path where, or the point on earth where you can stand and look at the total eclipse. Sometimes we call it for annular eclipse as well, but totality comes from the total eclipse. So during the 2019 eclipse, which is shown here on the screen, if you're in this bright pink region or in this globe you see here in this red region, then you could see the annular eclipse completely clearly without any disruptions. If you are anywhere outside, like in India, if you're in Delhi, or for that matter, even in Udupi, you would not see the total eclipse happening or the annular eclipse happening. So this path, the shadow of the moon takes, that's the best way to say it. Nobody is taking that path actually. The shadow of the moon is actually moving, okay, from here. And that path taken by the shadow of the moon, or to be more precise, the umbra of the moon, that is the path of totality. Regarding the calculations involved during an eclipse, I would like to say that it is basically celestial mechanics is what is involved here. It's basic mathematics. That's all. There's not much physics also. It's just mathematics there. If you can calculate the size of the planets, if you can calculate the size of the sun and all these things, then you can easily predict, easy, not for you and me, but machines can do it today. But you can estimate. Let me point out that whatever the ancient Indians measured, they were estimates. But today with computation, we can exactly measure where the umbra and the penumbra of the moon and the sun will move in. This is basic mathematics, but very complex calculations. The timing is also what matters, and so many other things. I will just show you a small animation here from a web page. There's a website called Eclipses, where if you go and search for this year's eclipse date, this is what you'll see. And here you see an animation of a shadowy circle passing in front of Earth. This is sun's point of view. And on the top, you will see one dot passing. Right now, you'll see a dot passing. That is that region where the umbra of the moon is falling. Here it's not even falling on the Earth. So that region where the umbra falls on the Earth, that is the path of totality. And unfortunately, these regions, like right now, you see Europe is under this penumbral shadow of the moon. And then slowly it comes towards India. And we are headed towards the sunset here. We are facing away from the sun at that point. So there, Gauri Bidnur will enter into the penumbral shadow. Okay. So that is where we'll see the penumbral shadow, or we'll see the partial eclipse. Okay. Penumbral shadow of the moon is not very much distinctive, so it's not possible, but that's where we see the partial eclipse. So the totality is where this dot moves. You can head over to Eclipsewise, ECLIPSEWISE, full single word, eclipsewise.com. There they have for almost 100 years, each of these eclipses, they have done this calculation. So the fact that they can calculate it means that it is basically a mathematical calculation to be done. There's not much physics involved. And regarding ancient Indians, yes, we Indians were smart enough. Aryabhatta has predicted eclipses to happen. Prediction of an eclipse is an easier path because that perfect small path is not the concern there. It is just the planetary alignment. So you just calculate when the last eclipse happened. Then you can basically calculate every 30 days, the moon is going to be in between the Earth and the sun at that point. then you will calculate when that 5-degree angle changes. So every new moon, the moon may be above from that straight line, so it may not be an eclipse. But there are going to be points. Okay, it's a mathematical calculation. I can't show it here right now. So there are points where the moon will exactly align itself, and they'll predict the eclipse. So not very easy mathematics, but it's all simple calculations from mathematics, where if you know the parameters right and the formulas right, it's very easy.
Can we move to the next question? Anybody has the next question, please?
ಸರ್ ನಮಸ್ತೆ ಅತುಲ್ ಸರ್.
ನಮಸ್ತೆ. ಹೇಳಿ ಸರ್.
ತುಂಬಾ ಚೆನ್ನಾಗಿತ್ತು ಸರ್ ನಿಮ್ಮ ಮಾತು.
ಥ್ಯಾಂಕ್ ಯು.
ಒಳ್ಳೆ ಯೂಸ್ಫುಲ್ ಸ್ಲೈಡ್ಸ್ ಗಳನ್ನು ತೋರಿಸಿದ್ರಿ ಸರ್.
ಥ್ಯಾಂಕ್ ಯು ಸರ್.
ಈ ಟೈಮಿಂಗ್ ಮಚ್ ನೀಡೆಡ್. ಸಾಕಷ್ಟು ವಿದ್ಯಾರ್ಥಿಗಳಿಗೆ ಅದನ್ನು ತಿಳಿಸ್ಲಿಕ್ಕೆ ನಮ್ಗೆ ಅನುಕೂಲ ಆಯ್ತು. ಸೊ ಫಸ್ಟ್ ಟೈಮ್ ನಿಮ್ದು ಈ ತರ ನಾನು ಕೇಳ್ತಿರೋದು. ನೀವು ಮೊನ್ನೆ ಧಾರವಾಡಕ್ಕೆ ಬಂದಾಗ ಬರಕ್ಕಾಗಲಿಲ್ಲ. ವೆರಿ ನೈಸ್ ಟಾಕಿಂಗ್. ಅಂಡ್ ಪ್ರತಿ ದಿವಸ ನೀವೇನು ಕೆಲವೊಂದು ಇವೆಂಟ್ಸ್ ಗಳನ್ನ ವಾಟ್ಸ್ಆಪ್ ದಲ್ಲಿ ಕಳಿಸ್ತಾ ಇರ್ತೀರಿ. ರಿಯಲಿ ಇಟ್ ಇಸ್ ವಂಡರ್ಫುಲ್ ವರ್ಕ್.
ಸ್ಟೂಡೆಂಟ್ ಸರ್, ಅದು ವಾಟ್ಸ್ಆಪ್ ಇಂದ ನೀವೇನ್ ಹೇಳಿದ್ರಿ ಅದೆಲ್ಲ ನಮ್ಮ ಸ್ಟೂಡೆಂಟ್ಸ್ ವರ್ಕ್. ಬಟ್ ಯಾ, ಥ್ಯಾಂಕ್ ಯು ಸರ್.
ಥ್ಯಾಂಕ್ ಯು.
Any other person? I think here at this point of time, I would like to ask to look at Eclipse 2.0, an app which you can download in your mobile, and you can see some thousands years back eclipses, 1000 years forward eclipses also. This is on information. Others, Lakshminarayana sir, you want to speak? A few seconds. You can unmute yourself. Can you unmute Lakshminarayana sir?
Hello, are you getting me? Are you getting me, Sina?
Please, sir, please go ahead. Anything you want to say quickly? 30 seconds.
Good evening, Sina and everybody. And good evening and special wishes for to Sri Atul Bhaji. And wonderful lecture you have given, sir. And okay, these grahanas and eclipses, lots of lectures we have heard. So let me tell you first who I am. My name is Dr. Lakshmi Narayana. I am from. I was a senior scientist in ISRO, colleague of and a good friend of Srinath actually. So I just retired recently. Had lots of lectures on eclipses, but every time, sir, whoever is the lecturer actually, one or other new thing will come out for us actually. So wonderful to know, sir, and very much impressed regarding this pack activities what you are doing. I think I suppose in Mangalore, is it?
Udupi. It is in Udupi. Atul is a serious preparing person. Any action is given, he will seriously prepare and present to the audience in the best efforts, sir. You are rightly appreciated him. Thank you, sir.
Very nice. One small point I'd like to mention, Sina.
Please.
Actually, I have a good friend, Dr. Raghunandan, director of.
I just want to ask him to speak. I will ask him. Raghunandan, can you unmute and speak?
No, Raghunandan is not here. I would like to say that Planetary Society of India named one organization is there in Hyderabad.
No, Raghunandan has joined here. You please allow him to speak.
Yeah, very nice then. Very nice. I don't know. Okay, good.
Raghunandan, you can unmute and speak before we close. Pani, please keep an eye on time. Mostly question session is over. Just only to take the feedback. Raghunandan, you can speak for 30 seconds. Are you able to unmute yourself, Raghunandan? I think something has happened, not there. Okay. Sir, anybody else? 30 seconds we will give with the permission of the speaker, because we don't want to keep him for a long time. Any person, if you wish, Venkatesh sir, you want to speak something? Just 30 seconds. Raghunandan is there. He can speak. He is unmuted.
Hello. Can you hear me?
Venkatesh sir, you can go ahead.
It was a very nice talk. In fact, see, you have specifically targeted the people at Gauribindur. I just want to know in Bangalore how will be the situation?
More or less same. Atul, I think you can answer.
Yes, sir. In Bangalore, it's pretty much the same.
Unfortunately, these days it is cloudy, and we may not be able to see that. Though I have seen two total solar eclipses, one in 1990 and the other in 1995.
Okay.
One in the Hubli in 1980
Okay.
and the other one in Agra in 1995. Wonderful.
Okay.
But I missed this 2010
Okay.
total solar eclipse in Indore because it
Okay.
was raining heavily in that.
Yeah.
And it will be really a wonderful experience to
View this.
see the total solar eclipse, particularly the corona and the diamond ring and so on. And anyway, it was a
Yes,
nice talk.
Thank you,
Congratulations.
Venkatesh sir. Atul Venkatesh, a senior retired professor, and is a
Okay.
president of Karnataka Physics Association.
Okay.
Maybe later we can
Sure,
introduce
sir,
you.
sure. Sure.
Raghunandan, if you are there, you can make your remarks because we are running out of time. Raghunandan is unmuted, but we are not able to listen to him. Fine. Anybody wants to make a point, please, you are feel free to make your remarks, and we will wind it up with a vote of thanks to the speaker. Maybe 30 seconds we will wait. It is open for all. Anybody, they can unmute and just speak, express their views. Panindra, after 30 seconds, you can take over and give a vote of thanks. Panindra.
Okay, sir. Okay, sir.
Yeah, Pani, over to you. I think nobody has any views. Please.
Okay, sir. Thank you, Atul sir, for making this eclipse more, informative because ಲಾಸ್ಟ್ ಸರಿ ನಾವು ನೋಡ್ಬೇಕಾದ್ರೆ ಸುಮ್ಮನೆ ಎಕ್ಲಿಪ್ಸ್ ಏನೋ ಅಂತ ನೋಡ್ತಾ ಇದ್ವಿ, ಬಟ್ ಅದು ಆಕ್ಚುಲಿ ಏನು ಅಂತ ನಮ್ಗೇನು ಗೊತ್ತಿರ್ಲಿಲ್ಲ. ಐ ಮೀನ್ ಮೋಸ್ಟ್ ಆಫ್ ದ ಜಾಸ್ತಿ ಸ್ಟೂಡೆಂಟ್ಸ್ ಕೇಳ್ತಾ ಇದ್ವಿ ಬಿಕಾಸ್ ಐ ಆಮ್ ಆಲ್ಸೋ ಸ್ಟೂಡೆಂಟ್ ಅಂಡ್ ಐ ಡೋಂಟ್ ನೋ ಮಚ್. ಐ ನೋ ದಟ್ ಎಕ್ಲಿಪ್ಸ್ ಅಂದ್ರೆ ಪ್ಲಾನೆಟ್ಸ್ ಮತ್ತೆ ಮೂನ್ ಅಕಲ್ಟ್ ಹೋಗುತ್ತೆ ಬರುತ್ತೆ, ಬಟ್ ಐ ಡಿಡ್ಂಟ್ ನೋ ಲೈಕ್ ಸೋ ಮಚ್ ಎಕ್ಸಿಸ್ಟ್. ಲೈಕ್ ನೀವು ಯಾವ ಪರ್ಟಿಕ್ಯುಲರ್ ಲೈನ್ ಅಲ್ಲಿ ಆಗುತ್ತೆ, ಲೈಕ್ ಅಟ್ ಸಮ್ ಪಾಯಿಂಟ್ ಲೈಕ್ ಪಾರ್ಷಿಯಲ್ ಆಗ್ಬೋದು, ಟೋಟಲ್ ಎಕ್ಲಿಪ್ಸ್ ಆಗ್ಬೋದು ಒಂದೇ ಟೈಮ್ ಅಲ್ಲಿ. ಸೊ ವಿ ಡಿಡ್ ನೋ ಆಲ್ ದಟ್ ಇನ್ಫಾರ್ಮೇಶನ್ ಅಂಡ್ ಥ್ಯಾಂಕ್ ಯು ಫಾರ್ ಗಿವಿಂಗ್ ದಿಸ್ ಇನ್ಫಾರ್ಮೇಶನ್. ಮತ್ತೆ ಇಂಪಾರ್ಟೆಂಟ್ ಇನ್ಫಾರ್ಮೇಶನ್ ನೀವು ಕೊಟ್ಟಿದ್ದೇನೆಂದ್ರೆ ಈ ಎಕ್ಸ್ರೇ ಶೀಟ್ ಇಂದ ನೋಡ್ಬಾರ್ದು ಅಂತ. ಮೋಸ್ಟ್ ಆಫ್ ದ ಪೀಪಲ್ ಎಕ್ಸ್ರೇ ಶೀಟ್ ಇಂದ ನೋಡ್ತಾರೆ. ಐ ಹವ್ ಸೀನ್ ಸೋ ಮೆನಿ ಪೀಪಲ್, ಈವನ್ ಮೈ ಫ್ರೆಂಡ್ಸ್ ಡಸ್ ದಟ್, and that now I'll inform them why you should definitely not see through the x-rays. And thank you for the information. Thank you for this whole talk, sir.
Atul, it was a quite good talk, interesting talk. Thank you for making your time.
Thank you, sir.
Convey regards to KV Rao sir and all
Sure,
your
sure,
team.
sure.
Let's work together in future.
Yes, sir, sure. Thank you.
Maybe
And
Panindra.
Thank
one
you.
more thing, Srinath,
Yes, sir.
KV Rao and myself, we were classmates and
Yes,
PhD
yes.
colleagues.
Yes,
together.
sir. I know that, sir.
Yeah,
Okay.
fine.
Pani, you can close. Atul, with your
Okay.
permission, we will be
Yes, sir.
closing.
Sure, sir. Sure, sure.
Thank you.
Thank you. Thank you.
Thank you. Thanks a
We are
lot.
closing the session now.